There is a method that costs nothing. Not $10, not $50, not a cleaner, not a spray. Zero. And a single application can restore EGR valve function in engines that most mechanics would tell you need to be disassembled and cleaned manually. Not temporarily. Not for a few days. But by restoring how the system was designed to operate in the first place. Japanese mechanics have been using this method quietly for decades. And the reason you've never heard of it has nothing to do with whether it works. It works extremely well. In the US and Europe, EGR-related issues follow a predictable pattern. First, a check engine light appears. Then, rough idle. Then, hesitation under acceleration. Diagnostics point to the EGR system, and the solution is almost always the same. Remove the valve, clean it, or replace it entirely. $200? $500, sometimes over $1,000, depending on the engine layout. Entire service categories built on one assumption, that once carbon builds up inside the EGR system, it has to be removed manually. But in Japan, the exact same systems, same valves, same materials, same engineering, often operate for hundreds of thousands of miles without ever being removed or replaced. Same system. Different outcome. They didn't redesign the EGR valve. They didn't use special coatings. They didn't change the materials. They changed how the system is used. And once you understand that, you'll start to see something most drivers never question. EGR failure is rarely sudden. It is gradual. And, more importantly, it is often reversible. To understand why, you need to look at how the EGR system actually works. EGR stands for exhaust gas recirculation. It redirects a portion of exhaust gases back into the intake system, not to improve performance, but to reduce combustion temperatures and lower emissions, specifically nitrogen oxides. But this process introduces something else into the system. Soot, carbon particles, unburned residues from combustion. Every time exhaust gas flows through the EGR valve, small amounts of these particles pass with it. And over time, they begin to accumulate. Inside the valve, inside the passages, inside the intake manifold, layer by layer. At first, this buildup is microscopic. Then it becomes visible. Then it becomes restrictive. And eventually, it interferes with valve movement itself. But here's the critical part most drivers, and many technicians, miss. Carbon buildup inside the EGR system is not chemically bonded like rust or corrosion. It is thermally dependent, which means it behaves differently depending on temperature. At low exhaust temperatures, carbon sticks and accumulates. At higher exhaust temperatures, carbon begins to oxidize. It breaks down. It burns off. And this is where usage pattern becomes more important than hardware. Modern driving patterns create the perfect environment for EGR clogging. Short trips, stop-and-go traffic, low RPM driving, low engine load. Under these conditions, exhaust gas temperature often stays below the threshold required to burn off carbon deposits. So instead of being removed, they build up continuously. Japanese driving patterns, and more importantly, maintenance philosophy, differ in one key way. Engines are regularly brought to full operating temperature. They are driven under sustained load, and they are allowed to reach the thermal conditions required for self-cleaning. Because at higher exhaust temperatures, typically above several hundred degrees Celsius, carbon deposits begin to oxidize efficiently. This is the same principle used in diesel particulate filter regeneration, but applied passively to the EGR system, and this is the part almost nobody explains. If you've made it this far, you already understand more about EGR systems than most drivers, and many technicians. Because what comes next challenges one of the most common assumptions in automotive maintenance. That carbon buildup must always be removed manually. In reality, under the right thermal and load conditions, the system can clean itself. This is the method, and it costs nothing. It's a controlled, high-temperature, high-load regeneration cycle. Here is exactly how it's done. First, fully warm up the engine. Not just coolant temperature, oil and exhaust temperatures must reach full operating range. This typically requires at least 10 to 15 minutes of continuous driving. Second, get onto an open road where you can maintain consistent speed. Highway or unrestricted road conditions are ideal. Third, increase engine load. Hold higher RPM than normal driving, typically between 3,000 and 4,000 revolutions per minute. This ensures sufficient exhaust flow and temperature. Fourth, maintain this condition continuously for 15 to 20 minutes. No short bursts, no interruptions. Sustained load is critical. Fifth, repeat this process over multiple drives. 2 to 3 cycles are usually sufficient for moderate buildup. Heavier deposits may require more repetitions. Here's what actually happens inside your engine during this process. As exhaust temperatures rise, carbon deposits inside the EGR system reach oxidation thresholds. At these temperatures, soot particles react with oxygen. They break down into gaseous compounds and are carried out through the exhaust system. Gradually, buildup inside the valve reduces. Passages begin to clear. Valve movement improves. Response becomes more consistent. Airflow stabilizes, and system efficiency returns. You are not forcing the system. You are restoring the conditions required for it to function properly. Fleet data and high-mileage usage patterns consistently show the same trend. Vehicles regularly driven under sustained load conditions experience significantly fewer EGR-related issues, less buildup, more stable operation, longer component life. In contrast, vehicles used primarily for short-distance, low-load driving show accelerated carbon accumulation. Same components, different usage, different outcome. Now, this is important. This method will not fix a completely blocked EGR valve. It will not repair mechanical damage, actuator failure, or electrical faults. If deposits have hardened to the point of full blockage, manual intervention may still be required. But in the majority of early and moderate cases, the issue is not permanent. It is operational. Your EGR system was not designed to function at low temperature indefinitely. It was designed with the assumption that it would periodically reach conditions where deposits are naturally removed. When that assumption is not met, the system degrades. Japanese engineers didn't design a different EGR system. They assumed a different usage pattern, and that assumption is the entire difference between a system that remains clean and one that clogs prematurely. If this changed how you think about EGR problems, share this with someone who's about to replace a component that might not actually be defective.